Physics students, Mr. Fig here. Once again, I want to look at another of these 1D motion problems. This one's a little bit more complicated because it involves more than one moving object. Again, to the right over here, I have the motion equations from the AP equation sheet, and I'll try to restrict myself to these equations only. Let's apply the 8-step plan and start going through this problem. All right, so I'm going to actively read and circle the information I think is important. A speeder traveling at 30 meters per second. Well, that seems important. Passes a parked police car. Parked is important for this. The police react immediately. That's important because immediately means that there is no reaction time for the police, that as soon as the speeder passes them, the police will start moving. Now, a word of caution, especially in AP physics, they will often do a version of this problem where there's a time delay before the police react. We'll look at one of those problems another time, but beware, right? Be on the lookout for that type of problem. If there's a time delay, then the police car will not start at the same time or origin as the speeder. Their car starts from rest and accelerates. Well, starting from rest is also important, and accelerates at 2.44 meters per second squared. How much time is needed for the police car to overtake the speeder? Now, this is a little bit tricky because we now actually have two things going on here. The speeder traveling steadily means that for the speeder there is no acceleration. That means for the speeder this velocity is both an initial and a final velocity. Because for the speeder there is no acceleration. But for a police car, let me change colors here. For the police car, this park, that means the initial velocity is 0 for the police car. The police react immediately and they start from rest, right? So there you go, they're starting from rest, and the police car accelerates. So the police car does have an acceleration. So this is really a problem involving two separate objects. So we need to ask ourselves, what is the condition for the police to catch the speeder? Well, for the police to catch the speeder, the police and the speeder need to be in the same place in the same time. So mathematically, what that means is to catch the speeder, the police need the same position and time as the speeder. So clearly, if you're stopping the speeder, you're going to end up in the same location at the same time. So what this becomes is actually two problems. We need to come up with a motion equation for the speeder, and we need to create a motion equation for the police. So let's make two lists of variables so we can keep them separated. So let's take a look at the speeder. And let's take a look at the police. Now, a little sketch here will be useful. So we have a police car, and we have the speeder. Now, the speeder is moving with a constant velocity of 30 meters per second. But the police is starting with an initial velocity of 0. But the police will have an acceleration. Now, I'm going to place the origin right here at when the speeder passes the police car. By placing the origin there, they both have a starting position of 0. So with that in mind, let's go and create our tables. So for the speeder, I do not know what their final position will be. But I do know, based on placing the origin where we did, that the initial position is 0 meters. For the speeder, the initial velocity is 30 meters per second. And that is also the final velocity, because for the speeder, the acceleration is 0. And I do not know how much time it will take for the police and speeder to end up in the same location. So on the police, again, I do not know what the final position will be. I know it has to be the same as the speeder, but I don't know where it will be. The police is also starting with a initial position of 0. Now, because the police is starting from rest, that is telling me that V naught is equal to 0. So I know for the police, V naught is equal to 0. I do not know the final velocity of the police car. I know the acceleration of the police car is 2.44 meters per second squared. And I do not know the time. All right. So this is going to be... So let's create our x equation for the speeder first. Now, for both of these, I do for the police car, I do not have a final velocity, so I'm not going to use this third equation. I need to know position, so I cannot use this first equation. So I'm immediately drawn to this second equation because that has the x and the t that I need. So let's do the speeder first. So I know x equals x naught plus v naught times t plus 1/2 at squared. Now, there's a lot of simplification to do in the speeder equation. Since the speeder has no acceleration, this piece completely cancels out. And since we're starting with the origin is when the speeder is at the police car, that cancels out. And the speeder equation, simply because, and I know what V naught is, it's 30. So I know that this position X simply becomes 30t, that is 30 meters per second times time. And that's a simple equation. Now let's take a look at the police. For the police, I want to start with the same equation. X equals x naught plus v naught t plus 1/2 at squared. Again, let's cancel out things that are 0. In the police case, the starting position is 0 and this initial velocity is 0. So that means that for the police, the equation becomes x equals 1/2 the acceleration, which is 2.44 times t squared. All right, so 1/2 2.44, I can actually simplify this a little bit, and I can say that x is going to be equal to 1.22 times t squared. Now, ordinarily, I would recommend that you keep everything in variables, but because we have two different sets of variables, it gets a little complicated. There are ways to do it in physics. For instance, for the speeder, I could put a prime on everything. I could say that this was x prime, this was x naught prime, right? I could also put s's on everything, so this would be xs, x0s. You know, it gets a little complicated. So right now, let's just set it up with the numbers that keep these separated. Now, this position needs to be the same position as for the police car as well as the speeder. So since I have two equations for the same position using the same time, I can simply set these two equations equal to each other. So I am going to erase my picture for the moment so I have some space. And I am going to write that the fact that x of the speeder must be x of the police. So that means 30t is going to be equal to 1.22 times t squared. Well, this t is going to cancel out with the square. Which means that 30 equals 1.22 times t. Which means that t is going to be equal to 30 divided by 1.22 seconds. Now, once I know what the time is, I can plug into either of these equations to find out what x is. So, for example, if I want to know the position for where the speeder and the police add up, I could use the speeder equation and simply say that x is equal to 30 times, well, you can put in whatever the value is. I'm going to leave it as just 30 over 1.22, and this answer would be in meters. So again, the hard part of most of these problems is understanding what's actually going on before you dive into the equations. I hope this helps as to how to approach these problems, and I'll see you in the next video.